Okay, so if you remember in the previous class, we talked about types of data. We said our data is divided into qualitative and quantitative, and we said the quantitative divided into discrete and continuous. Let's continue talking about data, and we talk about level of measurement. We have 4 level of measurement. So what does level of measurement means? It means this data, what can tell us or what we can understand from this data. Okay? So first level of measurements, we have the nominal level, which is the most primitive, or we call it the lowest level or the most limited type of measurement. It means the information getting from this data, it's just giving information, has nothing else to do with. As example, suppose there's data about students who sit for an examination. Hence, a nominal level of data is students who pass, they get B, students who fail, they get F. That's it. There is no more details about this data, okay? So the nominal level of measurement, so we collect data, and now we want to have measurement. We need to understand something about this data. So the minimum level of measurement, we call it nominal level, which give us the minimum level of information about this data, or what we call it the most limited type of measurement. As example, we have list of students. We just know about them that who pass get P and who fail get F. That's it, nothing else. Let's have example about the nominal level. As example, here we have, in the table here, we have that list of total units of 5 popular car models sold in Malaysia only. We just know that Myvi, they sold this amount, Saga sold this amount, Viva sold this amount, Persona this amount, and Vios sold this amount. There are just counts, as there are no measurements and no scales involved. We don't have any more details. We don't know that Myvi sold more than Saga. Okay, but what is the reason? They really produce more than Saga, or they produce less, and this is a percentage is higher or lower. We don't have any details. We just have a table of number of cars sold of each brand. Even here in this table, we are not discussing which brand or which car type is better or less, we call it negative feedback from customer, or less consumption of petrol. We don't know any of this at all. What we have in this level of measurement is the minimum level of information. It's like as I mentioned, like the count of cars only. Okay. So about level of measurements, the first or the lowest level or the minimum amount of information is in the nominal level. So nominal level, we call it the lowest or the most limited type of measurement. So as example, suppose there is a data about students who sit for an exam. So what we know that who pass get P and who fail get F. Other example also about nominal measurement, if we have a table has a number of cars sold of each type. That's it. We don't have any more details, and we cannot predict any more data or any more information from this table. Second type of levels of measurement, which is little bit higher than the nominal level, we call it the ordinal level. So what does ordinal level mean? Ordinal level describes the relation within a group of items in some specific order. For example, for a student with the highest marks in the class, he will be placed in the first rank, and the student who received the second highest mark will be placed as a second rank, and so on. So here we have the information, but we have ranking for the information also. And also the difference or the ratio between any two types of ranking is not always the same along the scale. Let me give you again explain about same example, which is students. Let's say the first student or who ranked the first he got 100 out of 100, okay? But second student who ranked as second, he get 80. Here the difference is 20 marks. The student who ranked third, he gets 70. So here the difference between second and third level is 10, is not 20, same as the first, okay? So here, while we have ranking, but still the difference or the ratio between any two types of ranking is not always the same along the scale. It's just kind of ranking for the information. Let's take example about the ordinal level. As example, we have the rating of final semester students, okay? So who get excellent, there are 8 students. Who get good are 27 students. Who got average are 29 students. And who got poor are 12 students. Here you notice that there is no certain difference or specific amount of difference between each level. Like here between 8 and 27 is 19 students. Between 27 and 29 is 2 students. So the difference between the rank or the difference between levels is not same. And that's what we call it the ordinal level. Here we can notice there is a relationship exists between the ordinal level categories. So here still there is a relationship that we know excellent is higher ranking comparing to the good, while good is higher than average, while poor is lower than average. So still there is relationship between those ranks. While when we go to the previous level of measurements, like the nominal level, there is no relationship between these ranks or between these numbers. We cannot say this one is higher or lower because we have still another things we need to consider, okay? While in our ordinal level, we can say that excellent is for 100% is higher than the good, while the good is higher than average and the poor is lower than average. So for level of measurements, we get now 2 levels of measurements. First is the nominal level, which we mention. The nominal level, which we mention, is a minimum or the lowest or the most limited type of measurement, which give us the most limited information. The second level of measurement, we have the ordinal level, which give us also ranking for the information, but still the differences between these ranks is not same, but still there is a relationship between these ranks. The third level of measurements we call it the interval level. I mentioned we learned first measurement level is the nominal level, which is the lowest or the most limited type of measurement. Just give us numbers, has no any relation between the numbers. And second level, we have the ordinal level. It has a kind of relationship between the categories, but still the differences between categories is not same. Third level, we have the interval level, which is include all the features of ordinal level. Now you will notice that each level is one step higher than the previous level. Like when we talk about the ordinal level, it's one step higher than the nominal level, and the interval level is one step higher than the ordinal level. So the interval level, it includes all features of ordinal level, classification and direction. It states that the distances between the categories is in constant size. If you remember, when we were talking about here, we said just excellent, good, average, and poor, but the distances or the differences between those categories is not constant, is not same. We cannot say that, yes, the good is less than excellent in 2 levels or in 2 degrees or in 2 points, while the average is less than good in 2 points. It's not constant, it's not same. But for the interval level, as I mentioned, it includes all features of ordinal level. State that distances between interval are same along the interval scale, so it is constant size. Popular example is the Celsius, the temperature, because we know that the difference between the 1 degree and 2 degree, it's similar than the difference between 2 degree and 3 degree and between 3 degree and 4 degree. Any level of this measurement, the differences, it's similar exactly, okay? So example, as I mentioned here, we have temperature of 3 consecutive dates for Shah Alam. We know the differences between the levels, it's same, between the temperatures is same. So this temperature can easily be ranked, and also we can determine the differences between the temperatures. We can easily understand that the 28 and 31 degree, the differences is 3 degrees, where those 3 degrees are equal to any 3 degrees in any another day, okay? And also the 31 degree and 25 degree, we can understand the differences between the degrees levels in the temperature, it's same. As I mentioned, when we say that 26 is higher than 25, the level it's similar than when we say 27 is higher than 26, especially in the temperature data. So the most famous example about the interval level is the Celsius or the temperature degrees. The type number 4 of measurement level, we have ratio level. I will remind you again, we are talking today about the level of measurements. We said there is 4 types of level of measurements. First level, we call it the nominal level, which is the lowest or the most limited type of measurement. Here, give us just numbers, just information, has no any relation among those numbers. As example, number of cards sold for each type of brand. Second type of measurement, we have the ordinal level, which has a relation between the categories, but the differences between categories is not similar. As example, we have the categories of students' marks. We have excellent, good, average, and poor. The third type of measurement level, we have the interval level, where we know the differences between categories, it's constant. The most famous example about the interval level is the temperature degree, the Celsius, how the temperature it is. And the type number 4, we call it the ratio level, which is the highest level of measurement, the most advanced level of measurement. As I mentioned, each level is one step higher than previous levels. So the ratio level is the highest level of measurement and has all characteristics of the previous levels, the interval level. Major differences between interval level and ratio level is ratio level data has a meaningful 0 point. Ratio between any given two numbers is meaningful. Divisions between the points on the scale have an equivalent distance between them. The most important point is ratio level data has a meaningful 0 point. When we study about the interval level, we talk about the temperature, the degree. When we say 0, it doesn't mean there is no temperature. It means the temperature is 0. But when we say, as example for ratio level, we have the high. When we say the high is 0, it means there is no height of the person. When we say the weight of this box is 0, it means this box has no weight at all, okay? So the ratio level has a meaningful 0 point. What is the example? Also, the rankings assigned the items are according to their size. As example, we have the money is a good illustration. Having 0 ringgit means you have none, you have no money. If you earn $40,000 a year and Apple is earning $10,000 a year, you earn 4 times than he does. So this we call it the ratio level of data. We have also, of measurement. The weight also another ratio level measurement. If the dial on a scale is 0, there is a complete absence of weight. So you need to keep in mind the main difference. So about the ratio and the interval level, they are similar, but the main difference that the ratio has a clear 0 point. Examples of ratio level, we have the weight, we have the height, we have the money, are very famous examples. about the ratio level. Example of differences between interval and ratio. Temperature is interval because, as we mentioned, when we say the temperature is 0 Celsius, it doesn't mean there is no temperature. It means the temperature is 0 and it can go to minus. Calendar time is interval. We don't have zero point in calendar time. Calendar time is a day, like first, second, third day. We don't have zero time in calendar time, okay? There is no 0 point. The height, weight are ratio, the salary are ratio, because we have the 0 point. If the height is 0, it means there is no height. There's absence of height, same as the weight. There's absence of weight. When we say the salary is a ratio, because when we say 0 salary, it means you don't have salary, okay? So the main difference between the interval and ratio is the 0 point. There is a 0 point in the ratio level. So as we said in today's class, we have 4 types of measurements. The nominal level, which is the minimum level of information, as like counting number of cars. We have the ordinal level, where there is relation between categories, but the differences is not same. As the level of students' achievement, we have the excellent, good, average, and poor. We have the third level of measurement, which is the interval level, which is the differences between levels is in constant size as the temperature, but the ratio level is different than the interval level because we have the 0 point, which means the ratio level data has a meaningful 0 point. As example is the height, weight, and money. So, as a summary of what we learned today, we have 4 levels of measurement. The first level is a nominal, which is categories as type of flowers, as gender, male and female, but we cannot say which one is higher or lower. There is colors, car brands. The ordinal level, which is categories plus ranking, like class rank, as we mentioned, excellent, good, average, and poor. Socioeconomic status, as we have in Malaysia here, the T20, the M40, and the P40. We have the interval level of measurement, like it has categories, rank, and equal interval, like the time period and the temperatures. The ratio level, which has categories, rank, equal, and true 0 point, as example, age, weight, height, time to complete task. Here you need to keep into consideration the difference between time to complete task and time period in the interval level. Time to complete task, it has 0 points. When we say 0 point, 0 time to complete a task, it means task done directly. We don't need to spend time to do. It's just like the task will be completed just by pressing a button. So there is no time for it. So it has 0 point. But time period has no 0 point because there is in the time calendar we have days. We don't have 0 point. There is no absence of time in calendar. Good. So let's start with today's class. We were talking about types of data before. So today we will talk about how we do the sampling. If you remember, in the previous class, we'll talk about the sample and population. And we said that the sample is a group of the population where we do our study on it. Then we can generalize the results. So the learning outcome of today's class, by end of the class, you will be able to explain the meaning of sampling and methods of sampling available, apply sampling method to a population, explain different methods of data collection and their suitability, and design questionnaire. So first, let's talk about what does sampling mean. Sampling is a process of selecting a sample from population. If you remember the previous class, we defined the sampling. And we said so in many cases, we cannot apply the study on the population. We have to choose a sample, and that sample should represent the population, all of it. Then we apply our study on it. So since the data obtained from a sample is used to generalize the result or make conclusion about population, so the sample must be selected in a such way that it will accurately represent its population. We need to be very careful when we are choosing our sample. We cannot just rely on whatever sampling we see, or we just decide. Actually, some types of sampling methods, you are the person who is taking the decision. Who are the sample and what is the sample? But to be more clear and to be able to defend your conclusion about the population, you should be very clear what type of samples you are using and what type of sampling method you are using and what is the content of your sample, to be able to defend that this sample is really representing the population. So appropriate sampling technique is must to be used, and sampling technique are scientific methods of selecting representative samples from population. Samples selected must be random and representative of all respective populations. So the main point we need to consider when we are doing sampling is that this sample should represent the population. It's very important to this sample to represent the population. Then the sampling technique used in each study, it depends on the characteristics of the population of interest. So here, also we cannot say there is one sampling technique is successful for all types of studies, or one sampling technique we can use for all types of population. No, it doesn't work like this. And the sampling technique, we can decide to use this type of sampling technique. It depends on the characteristics of the population. These include factors such as homogeneity or heterogeneity. You know the difference between homogeneity and heterogeneity. The homogeneity when is the items of the population all are similar or they have same specifications. The heterogeneity, the items of the population are different. They are diverse in character, okay? So as example, let's say if you are talking about Malaysia, so Malaysia it has different states, and each state it has different characters. The people in each state has different characters. So when we talk about Malaysia in general, we can say that this population it has heterogeneity. Okay, the population is heterogeneity. But when we say in one state of Malaysia or in one district in one state, let's say that Cheras district in Kuala Lumpur, okay, because you know like Kuala Lumpur is divided in 4 districts. So let's talk about Cheras. So Cheras, we can consider it has homogeneity because the items of Cheras, or what we call it, the population of Cheras, it somehow has homogeneity. Somehow they have similar specifications, okay? So any member of it can represent the other members, okay, as specifications. So when we are choosing the sampling method, we take into consideration the characteristics of the population itself. So this including if the population is homogeneity or heterogeneity. Also the availability of the sampling frame, list of individuals or items from which the sample can be obtained, because in some cases we don't have list of the population items. We don't have list of individuals. We can choose the our population or our sample from it. So also here the sampling method will be different. Also the research budget. Also this is another point, because when we have limited budget, we need to limit our sample or to choose a specific sampling method which is more suitable to our budget. So when we are deciding the sampling method, we take into consideration 3 points. First, the homogeneity or heterogeneity of the population. Second, the availability of sampling frame, which is a list of individuals in the population. Third, the research budget. So those 3 points we need to take into consideration when we are deciding the sampling method. In general, we have two classification for sampling method, and under each of this classification, we have different methods. You remember when we were dividing the data to quantitative and qualitative, and under the quantitative, we have discrete and continuous. So here also for sampling method, we have two main categories. Under those categories, we have sub sampling methods. So those main two categories, we have the non-probability sampling technique and the probability sampling technique. Those two main types of sampling techniques. So first is the non-probability sampling technique. Second is the probability sampling technique. So let's talk about the probability sampling technique. What are they include? We will talk about it. In general, researchers prefer to use a probability sampling technique to ensure that their findings are valid, as well to allow them to make inferences on the population. Because non-probability sampling technique, here the judgment of the researcher is playing a big role, and the researcher somehow he is a decision maker in deciding what item or what part of population to be included. So here when he or she, when they will take a decision about a specific about the population, or when they will announce their results, maybe they will find some people saying no, your results um, are not right because you use what we call it non-probability sampling method. So those sample who already collected, those sample which you used for your decision, they are not representing the population in right way. So like this, the result can be not accepted by some people. Okay. So for that reason, most of the researchers, they prefer to follow the probability sampling technique because we can consider it more stronger and more, there is no human touch in choosing the sample. So let's first talk about the non-probability sampling techniques, then the probability sampling techniques. So I want to remind you again, today's class is just about sampling techniques, okay? It's very important to keep those things in mind. If you remember the previous classes, like the previous class, we talked about only the measurements, okay? We didn't the measurement levels. Why we give one class for measurement levels? Because it's very important to keep these measurement levels in your mind. When you are moving forward to do your research, to do your data collection, you need to be very aware what type of data you are looking for, what type of study you are looking for. You want quantitative or qualitative, what type of measurement level you will be used, and here what type of sampling method you will use. So if you are not aware or very clear about those things, you cannot proceed further. So for that reason, I'm focusing a lot about these things to make sure that you really can do a real research, okay? Which is a clear in answer in the results, and there is no issues on it, okay? So we continue about the techniques or the sampling techniques. We said that we have two main categories, which is the non-probability sampling techniques and the probability sampling technique. So the non-probability sampling techniques, we have four types. We have the convenience sampling, we have the judgmental sampling, we have the snowball sampling, and we have the quota sampling, okay? So we have convenience sampling, judgmental sampling, snowball sampling, and quota sampling. So let's go with the convenience sampling, okay? So the non-probability, what is the non-probability sampling techniques? The non-probability sampling techniques are used when the generalization concerning the population is not important, and at the same time the sampling frame where the sample is to be selected is not available or it's difficult to obtain. So the sample frame, or what we call it, the list of individuals in the population, is not available. For that reason, we use one of the non-probability sampling techniques. So the sampling techniques, as we mentioned, we have two types, two categories, non-probability and probability. The non-probability, normally we use it when the generalization concerning, and when we don't have the sampling frame, or what we call it, we don't have the list of individuals where we can pick up our sample from. The non-probability sampling techniques, we have four types. We have the convenience sampling, we have the judgmental sampling, we have the snowball sampling, and the quota sampling. So let's see each one of it, what does it mean? Let's start with the convenience sampling. Convenience sampling mostly represent that we don't have access to all the population or all the individuals of population, and in some cases we don't have budget to do that. So the researcher will choose the people which he know from the population, but based on his convenience. Okay. So, as I mentioned in the convenience sampling, the researcher will use his relations and will choose the sample from the people he is convenient to talk with them or deal with them or to reach to them. While some people they take against this sampling method, that this sampling method, those sample or those people who have been chosen, maybe they are not representing the population. So we cannot generalize the results. But we said this still is one of the sampling techniques. So what is a convenience sampling technique? Is a procedure where the researcher selects respondents at his own convenience using this method. The selection of respondents is at convenience of a researcher. Often the respondents are selected because they happen to be in the right place at the right time where the researcher is conducting survey. So the convenience method for selecting a sample, it is not relying on any other mathematical procedure or anything. It's just based on the researcher convenience. As example, the researcher is conducting a survey at the entrance of a shopping complex at 10 a.m. So in the morning. So anyone passing from the entrance of that shopping mall at 10 a.m., so it will be part of the sample. That's it. But here we see that the researcher didn't study that what is the number of people entering the shopping mall and what time they are entering, then he can decide what time to go. He just said, see, the 10 a.m. is more convenient for him, so he just proceed to collect data from those who are entering the shopping mall at 10 a.m. This image, let me just make it bigger for you. This image somehow showing very clear about the convenience sampling. We can see here, this is the researcher. This is the researcher, and here you see how he chooses the sample from the people he is more convenient to be with. Maybe the closest people to him, maybe, as we mentioned, the people who are available in the time he decided to do the data collection. So this, we call it a convenience sampling. So is it possible that this sampling happen? Yes, it's happened, and some researchers they are doing. Why they are doing, as I mentioned, in some cases there is a limit budget, and in some cases it's difficult to access to others. So let's say you are doing data collection where the VIP people or some of the politicians, you cannot access to them. Even you try to send, you try to choose some of them because they are more suitable, but it didn't work. Then you try to, whoever from those a politician or those VIP answer you, you just consider it as your sample. Okay, because you have connection with their secretary or they are part of your family member or so on. So sometimes, yes, we are in need to do the convenience sampling because we do have limited budget or limited access to the population. So this is the first type of the non-probability sampling techniques. We have the other type. We have the judgmental sampling technique. The procedure of selecting respondents for research solely based on the judgment of the researcher. The researcher selects a respondent whom, from his judgment, he feels possesses certain characteristics that represent the population. From his point of view, he do believe that those people are okay and they are fulfilling the characteristics. Let's take the example. So our previous example was convenience, and he just see that it is suitable for him to go at 10 o'clock morning to the shopping mall, so he collect answers from those respondents. In this example, we are talking about the judgmental sampling, that this is the judgment of the researcher. As example, if our researcher want to collect data about those illegal traders who are selling pirate CDs. You know, in some countries, selling pirate CDs, it's illegal. So he is trying to collect data from those people. Maybe he's trying to ask why they are doing this job, what is the benefit, what is the pros, what is the cons. So he needs to collect sample or collect data from those people, but accessing to those people is not easy. So he needs to use his judgment to find who is really selling the pirate CD. As example, he can see that the shop is not a proper shop, maybe like a simple kiosk in a corner or in a kampung area, like is not that much proper shop. He will find those people mostly they are looking suspicious because they know they are doing illegal job. So he will consider them as as a sample, and he will do the data collection. So the judgmental sampling, it's relying a lot on the judgment of the researcher himself, and he will be the decision maker to decide whether this person is really representing the population or not. So as this is a photo is representing the judgmental sampling. If you see that here we have, if you see, here we have the population. This is our population. And this is the researcher, he will be the decision maker. Which one of this population can be the sample? Then he will choose the sample. So the judgmental, all the people which is possible to be population, he will be the decision maker to choose the sample based on his judgment that those people that are really fulfilling the characteristic which he is looking for. Then we have the third type of non-probability sampling technique. So now we learn about the convenience sampling technique. We learn about the judgmental sampling technique. Now we have the third type of sampling technique, which is a snowball sampling. Why it's called snowball? If you remember in the cartoons, we see that always they try to make small snowball. Then when they push a little bit, it will get bigger and bigger and bigger, then to be very big snowball. And this is the reality of this sampling technique. So this sampling technique rely on, I need to find the first person in the sample, which is fulfilling the characteristics of the sample I'm looking for. Then I will try to ask him for a second person which he knows having same characteristics. Then from the second person, I ask him for the third person, and so on. So for that reason, it's called snowball, because we need just to start with one person, which is, in our point of view, is fulfilling the characteristics. Then we ask him for the rest of the sampling item. So the snowball sampling is the procedure of selecting the subsequent respondent based on information provided by earlier respondents. And the process continues until enough respondents are obtained. The researcher only needs to identify the first respondent who possesses the characteristics required by the study. Let's take example. If our researcher, he is trying to do a study of victim of quick rich scheme. I think all of you already know what does it mean, that you receive email You will be a billionaire within 2 days. Wow. And those some people they'll be victim of these schemes and they will invest money and all of this. But mostly the information of these people is not available. So if our researcher he is looking to make a study about those people which are victim of quick rich scheme, but he cannot find them. There is no data available about them, so he needs to find the first person. So the researcher has no sampling frame, it means he has no list of respondents. So he needs to identify first victim, then ask him or her for other victims he knows. Let's see this photo, which is explaining the snowball sampling technique. You see, this is the first respondent we know based on our research. And this is the first person which we know that he already was a victim for the speed reach scheme. That this person he knows that two of his friends they were a victim for the same issue, and this person he knows three of his friends. This one he has three of his friends, and then this one will get another friend till we reach to the desired number of items. So this is what we call it the snowball sampling. We need to find the first one first, then we proceed with the rest. Okay. So now we learn about three types of the non-probability sampling technique. First was the convenience sampling technique. Second was the judgmental sampling technique. Third is the snowball sampling technique. The type number 4 under the non-probability sampling technique, we have the quota sampling. Quota sampling is a procedure of selecting respondents who possess certain characteristics determined by the study. The sampling process is quite similar to the convenience. You remember the convenience, which is more convenient to us, but here we are adding some more details or some more restrictions by adding some characteristics. So the quota sampling, it's somehow similar to the convenience sampling, but it differs in terms of flexibility to choose the respondents. He wants provided they abide by the stated specification. You remember when we were talking about the convenience sampling technique, we said that the researcher can go at 10 o'clock to the shopping mall and start on the door, and who are entering at 10 o'clock, he will take the answers from them. So if we want to make it as a quota, yes, it will be convenient. He will go this time, but he's gonna to choose only the female shoppers. So his main concern are the female shoppers, not the male shoppers. So even if a male shopper entered the shopping mall, he's not gonna to take it as part of the sample. So this we call it as quota sampling. It's convenience, but still we have some more specifications we need to take into consideration. So the quota sampling, as here we have in the photo, I think is clear for you. So here we have the population, and you see how he take into consideration a specification which is male and above 50. So from this population, he need to choose the male which are above 50. So he will choose this sample. Okay. So here you see how the quota sampling it works. This is a population. He want to choose convenience, and then he need to add some more details, so it will be quota sampling. Like he need just to choose a male which are above 50 without any another consideration. Okay, so this we call it the quota sampling. So like this, we finish what we call it the non-probability sampling techniques. If you remember, we said the non-probability sampling techniques, there are four types of techniques. We have the convenience sampling technique, convenience sampling technique, we have the judgmental sampling technique, we have the snowball sampling, and we have the quota sampling. You remember we were in the previous session in the first session of the class, we were talking about the non-probability sampling techniques, and we mentioned we have 4 types of non-probability sampling techniques, which are the convenience sampling, the judgmental sampling, the snowball sampling, and the quota sampling. We explained each one of it. We said the convenience mostly is the researcher will choose a sample based on his convenience, and we took this photo as example for the convenience sampling technique. As you see, the researcher, he chose the people which are more close to him to represent the population. So let's continue. The second type of the non-probability sampling technique we mentioned is a judgmental sampling, where the researcher uses his judgment to choose the representative of the population. We give the example here that the researcher, he wants to collect data about those who are selling the pirate CDs. So based on his judgment, he do believe who are selling the pirate CD, they will have a non-proper shop. They will be always feeling very curious. Okay. Then we have the third type of non-probability sampling technique. We call it the snowball sampling technique, where the researcher, he needs to figure out the first respondent enough to decide to get the rest, because he will deal with the first respondent. Then he will ask him if he knows others that are having same characteristics. Then they will go to second one. Then from second one, we'll ask about others, and so on. This we call the snowball sampling. And the type number 4 of the non-probability sampling techniques is a quota sampling. It's very similar to the convenience, but we do some more characteristics for our sample. Like example here, this is the population. We choose men which they are above 50. That's it. Okay. So those are the non-probability sampling techniques. We have another category of sampling techniques. We call it probability sampling techniques. We have 4 types, which is a simple random sampling, the systematic sampling, the cluster sampling, and the stratified random sampling. So we have 4 types of the probability sampling techniques: the simple random sampling, the systematic sampling, cluster sampling, and stratified random sampling. So what is the probability sampling techniques? Just 1 minute. Okay. So what is the probability sampling technique? So probability sampling techniques are used when a researcher plans to make inferences about the population, and the sampling frame where the sample is to be selected is available. So here we have the sampling frame available. Let's say our study is about the SMEs in Klang Valley. So the list of SMEs in Klang Valley is available. We can go and get it from the government, from a specific government department. If I want to do my research about those who are having kiosk in the Ramadan Bazaar, so also I can go to the manager of the Ramadan Bazaar in the area I'm looking for, and I can get a list of the people who are having kiosk in the Ramadan Bazaar. So the sampling frame is available. So we choose a probability sampling technique. Sample is selected from a population in such a way that each item has same chance to be selected. So here is totally different than the non-probability. The non-probability, we are the decision maker, and not everyone has a chance. If you remember when we were talking about the convenience sampling, we choose the people who we know them, or we choose our judgment. So not everyone in the population has same probability to be selected. But in the probability sampling technique, each item of the population, each person in the population has same possibility or has same chance to be selected. And the type of probability sampling techniques to be used depends very much on the characteristics of the population itself. The characteristics of population could either be homogeneous or heterogeneous. Again, here, we need to consider the characteristic of the population. And we said, and these characteristics will help us to choose which one of the probability sampling techniques we will take. So either the population, or what we call it, the characteristics of population is homogeneous, it means all items that are having same characters, or is heterogeneous, which is diverse. So let's see what are the probability sampling techniques. As we mentioned, we have the simple random sampling technique, we have the systematic sampling technique, we have the cluster sampling technique, and we have the stratified random sampling. Let's start with the easiest one first, what we call it simple random sampling. In the simple random sampling, a simple random sample is used when the population is homogeneous. We need to keep it in our mind. When we use the simple random sampling, when our population is homogeneous, and the sampling frame is available. This is also another point we need to take it into consideration, that our sampling frame is, sorry, what just, yeah, okay. Our sampling, when we use the simple random sampling, we use a simple random sampling when our population is homogeneous and the sampling frame is available. It means the list of the population or list of respondents, list of people in the population is available. So this sample is selected from the population in such a way that each item has the same chance to be selected as a respondent. So I will repeat again. Simple random sampling technique is a probability sampling technique. We use it when our population is homogeneous and sampling frame is available. And in this sampling technique, each item has the same chance of being selected as respondent. To obtain a sample using this method, the researcher first needs a sampling frame, or what we call the list of population. Then random samples are generated to determine which elements are to be selected as a sample. So as we mentioned in the random sampling technique, when we use the random sampling technique, we use it when our population is homogeneous. It means all they have same characteristics, there is no diversity, and the sampling frame is available. Each item in the population has the same chance to be selected, and the first things the researcher need to have is to obtain list of population, then a random numbers will be generated. So let's take example. A sample size of 10 to be selected from a list containing names of 800 people in a certain housing area. So we are doing our research in a sample house in a housing area. So we are doing our research in a housing area, and we have here 800 people living in that area. So we want to collect 10 respondents, okay? So a sample size of 10 to be selected from a list containing names of 800 people in a certain housing area. This can be done by generating 10 random numbers from 1 to 800 using a random number generator on computer. In this case, all the 800 people have an equal chance to be selected in this study. That's it. So again, I will repeat, the random sampling, we use it when our population is homogeneous. It means they are having same characteristics, and we have the list of respondents. And we need just to have the list of the people in the population. Then we can generate the number randomly. So as example, if you want to do our research, let's say I want to do my research about the Kampong Baro, houses, okay, from those people. So I can get this list from the district management. Then I can see that, let's say we have 800 houses in the Kampong Baro area. So I want to use it as a simple random technique. So I just put the names in the computer, and we have some softwares they will do auto generating for the random sampling. So we just press auto-generate, we choose 10 samples, and that's it. This is how we do the simple random sampling. Here, each one of the population will have same chance to be selected like others. This is the photo which is representing the simple random sampling. We don't have any specific character or specific decision or specific even interference in choosing the sample. It's just auto-generated. That's it. And mostly this type of sampling, the sample will be collected. It's representing the population because it's just auto-generated and our population is homogeneous. It means each person is having same characteristics like others. So it can represent the population. Second type of the probability sampling, we call it the systematic sampling. Systematic sampling is also used when the population is homogeneous. Also, this is another point we need to keep considering it. You remember when we talk about the random sampling, we said the population should be homogeneous, okay? And the sampling frame is available. In the systematic sampling, the researcher divides the population size, which is the N, big capital N, by the intended sample size, which is the small n. We need to use what we call it this equation. We need to use this equation for our sampling. We need to divide the population size, which is the capital N, on the intended sample size. Like I have my population is 100 and my intended sample size is 10. Then we choose one number randomly. So let me give you an example because somehow maybe it will be difficult for you to understand it from the equation. Our example is the population is 100. Okay, it means our capital N is 100. This is our population is 100 and intended sample size we are looking for is 10. So based on the equation, we need to divide the population size on the sample size. So 100 divided on 10. So it will be equals to 10. Okay. So we put the equation. We need to divide the population size on the intended sample size we are looking for. So our population is 100. The sample size we are looking for is 10. So we divide 100 divided 10. We have 10. So the first step to do our sampling, we need to choose a random number between 1 and 10 because our number is 10 here. So we need to choose a random number between 1 and 10. Let's say we selected 4. Then we start adding 10 for each. So our first respondent is 4, second respondent is 14, 24, 34, 44, 54, 64, 74, 84, and 94. So like this, we call it a systematic sampling. So you remember, I will remind you again, in our previous sampling technique, we used the random sampling. We just key in the 100 names and we ask the computer to generate 10 names from those 100. That's it. There is no systematic things. Just the computer will do the generating randomly. Second way of probability sampling is systematic sampling. We divide the population size on the targeted sample size. So our population is 100, our targeted sample size is 10. So we divide 100 divided on 10, we get 10. So here we have this number we need to take into consideration. Then how we start? We don't start from number 1, no. We need to choose a number between 1 and 10, which is the first part. So let's say if this one was not 10, if this one was 5 as example, okay? So we need to choose a number between 1 and 5. If this one was 3, we need to choose a number between 1 and 3, okay? So as we mentioned, first step, you need to divide the population on the sample. Second step, you need to take a number between number 1 and the number which you get, which is we call it the k. So you choose a number between 1 and the k. The k in our example here is 10. So you choose a number between 1 and 10. Let's say we choose 4, or let's say we choose 5, okay? I choose the first one will be 5. So how I will collect, or I will decide which are the 10 items in my sample. So it will be 5, I will add 10, 15, 25, 35, 45, 55, 65, 75, 85, and 95. Like this, I get 10 respondents as my sample. So the systematic sampling, it's very easy. You need just to know the population size. You need to know the sample size you are looking for. Just divide the population on the sample size. Then you will get a number. Whatever this number, let's say this number is 8. Then you need to choose a number between 1 and 8. Let's say you choose 6. Then you need to add 8 on each 6. Okay? So you choose 6, then you add 8 on it. Then you need to choose 14, then you add 8 to it, then you choose the 22, and so on, okay, till you get your sample size. So like this, we explain two types of the probability sampling, which is the random sampling technique and the systematic sampling, which are both easy. Then we have the third type of the probability sampling technique. We call it the stratified sampling technique. The stratified sampling technique, let me see, where is the photo? Okay. So the stratified sampling is also used when the population is heterogeneous. Here we need to take into consideration our population is heterogeneous, but the sample frame is available. You remember the previous two ways of the data sampling, which was the random sampling and the systematic sampling. Our population was homogeneous, which means all the items having same characteristics. But here, when we are talking about the stratified sampling and later the cluster sampling, our population is heterogeneous. We need to take into consideration that our population is heterogeneous. It means the people in the population are not having similar characteristics. So our population is heterogeneous. The researcher divide this heterogeneous population into several homogeneous strata. So here, we need to take the entire population, divide the population to the similar homogeneous strata, then we do a random sampling inside. So stratified samples may be proportionate or disproportionate. Elements within each strata should be homogeneous, whereas the difference between strata should be heterogeneous. So again, when we apply the stratified sampling, we apply the stratified sampling when our population is heterogeneous. It means the people inside this population, they are not having same characteristics, and we should have the sampling frame. We need to divide this population to strata, to parts, and each one is homogeneous. Like let's say we divide men, women, or let's say those age less than 20, then age from 21 to 35, then from 36 to 50, then above 50. This is as example, because we cannot take all the population which are they having different ages as homogeneous. No, this one is heterogeneous, especially if the age playing a good role in our study. So stratified sampling is a two-step process in which population is partitioned into strata. Stratification of the population is needed in order to obtain several homogeneous subgroups. So the steps of the stratified sampling, we divide our population in different groups. Each group is homogeneous, but is heterogeneous with other. Let's say we divide our population to 4 groups. Those group, inside each group, the items of each group are homogeneous, which is others. It means similar to each others, but they are different than other groups. They are heterogeneous with other groups. If you are dealing with a population is very diverse, and if the population can be subdivided into subgroups that are homogeneous, we will achieve better results. Those are subdivision or stratification. Next, elements are selected from each stratum by random sampling. We go inside each one of those groups, we do a random sampling. So researchers prefer stratified sampling due to several reasons. Firstly, the researcher could analyze each group separated, then can compare the results. Second, statistical analysis based on stratification is more accurate since data come from a homogeneous population compared to non-stratification where the data comes from heterogeneous population. So to decide which sampling technique we need first to decide whether we need to use random probability or non-probability. So most probably we need to go to probability 1 to make our decisions stronger. Then we go to decide from the probability which type of the sampling we will use. First, we need to see our population is heterogeneous or homogeneous. The people inside that population are similar or different. So if they are homogeneous, we can use the first two, which is the systematic sampling or the random sampling. If they are heterogeneous, we can use stratified sampling or cluster sampling. Stratified sampling, we need to divide that population to a separate group. Each group, they have homogeneous item. So for that reason, people they are using the stratified sampling because when we are just taking the entire population which has heterogeneous item, our results will not be that much accurate. So this is the example about the stratified sampling. This is our population, as you can see here. This is our population, as you can see. Then he divided based on the gender, as based on the age. So here he chose the one group which are the old people. Then he chose the younger ones. Then he chose the youngest in the group. So like this, this group or this population, they are heterogeneous. They are coming from different ages. So to make it easier, especially like maybe in this study, the age is playing a role. So to make it homogeneous, he divide based on the age, like old people, like younger groups, and the youngest group. So he divide them based on the age. This we call it stratified random sampling. Then from inside each one of those stratums, he will choose the sample in a random way. That's it. The last, or not, it's not last, though, we still have one more. We have the cluster sampling. Cluster sampling somehow similar to the stratified sampling, but here we cluster based on the geographical areas. A cluster sampling is used when a population interest is scattered widely across certain geographical areas and the sampling frame is available. So when we use the cluster sampling, we use a cluster sampling when the population is scattered widely across certain geographical area and when our sampling frame is available. In those two way or in those two specification, we will use the cluster sampling if our population is diversified among certain geographical area and if the sample frame is available. First of all, the researcher divide the target population into some clusters based on the geographical areas. Then a random sample of cluster is selected based on the probability sampling technique. As example, if you want to do data collection in Malaysia, so you know Malaysia, It has different states, so you can divide your population based on the states, then choose from this state the random sampling. For each selected cluster, the researcher could use all population as respondents for the study. Cluster sampling is more economical and efficient since the researcher focuses more on selected clusters. If the sampling frame for individual elements is not available or incomplete, cluster sampling provides a good alternative method. Because you remember for the stratified sampling, we need to have the sampling frame. But in the cluster sampling, we still need the sampling frame, but when it is not available, still there is possibility to use the cluster sampling. So here as example, we have the cluster sampling. This is our population. In this example, okay, this is our population. All of it is our population. Then the researcher, he divided this population into different clusters. You see, those clusters have been divided based on the geographical area. Then he chose just 2 clusters from those clusters to represent the entire population. Then the last type of data of sampling method, we call it the multi-stage sampling. Here we go in different stages. Multi-stage sampling is designed to reduce time and cost when working with the samples, which are very large population. So we need to go in multi-stage. So let's assume we need a random sample of 2,000 residents from the Malaysian population. Since Malaysia consists of 14 states with many districts within each state, so many villages within each district, we could apply the multi-stage sampling technique. How we can apply it? First, we select 4 states randomly. We know that Malaysia, it has 14 states, so we select 4 of those 14 states, okay, based on our study. Then we choose 5 districts randomly from each selected state. So first, from 14 states, we choose 4 only. Then from each one of those 4, we choose only 5 districts. We know sometimes each state have more than 5 districts, so we choose 5 districts only randomly from each state. Then we select 100 individuals in a random selection based from each district. Okay, so we have, as we mentioned, 4 states. From each state, we choose 5 districts. So we have now 20 districts. We choose from each one of these districts 100 people randomly. This we call it a multi-stage. We call it this a multi-stage sampling method. Therefore, we only collect the data from 20 relatively small areas instead of having the 2,000 houses or 2,000 areas. Okay. So like this is the end of our session today. Today we learn about the sampling techniques. If you remember, we started our class today with the types of the sampling techniques. We said we have nanoprobability and probability. Then from nanoprobability, we said we have convenience, judgmental, snowball, and quota sampling. And from the probability, we have simple random sampling, systematic cluster sampling, stratified sampling, and the multi-stage sampling.